reminder, today we are reviewing the three equations of a line, how to graph an equation of a line, how to write an equation of a line, given information about it. Okay? So, three forms of a line. First one, slope-intercept. Anybody remember what it is? Y equals mx plus b. That is correct. Y equals mx plus b. Where m represents the slope and b represents the y-intercept. Y equals mx plus b. Remember, the y-intercept tells us where the line crosses the y-axis. So if you're given an equation in slope-intercept form, you look at where it crosses the y-axis, and you would put a dot there, and then from there you would apply the slope. Anybody not have the stapler yet?
Over here.
Over here. All right? Any questions on slope-intercept? We're going to do some examples. Any questions? Anybody not done copying it down other than Paul? Ready to move on. Paul's not done. Just kidding you, Paul. Paul. He's from Paul. Okay, standard form. Does anybody remember what standard form looks like? Okay, it's a good thought. Any others? There's an A, that's right. AX plus BY equals 0.
Oh, I know.
C equals C, sorry. Equals C. AX plus BY equals C. The key is, if it's going to graph a line, A and B can't both be 0. If A and B were both 0 at the same time, it would not be an equation of a line. A, B, and C must be integers. So no fractions and no decimals. And the one that's in blue, I'm going to blame that on your chemistry teacher. When you use this in chemistry, A has to be a positive number. I'm not sure how it applies. I've had just a short conversation with him. I don't know in what context you use it there, but the fact of the matter is, in chemistry, this equation of a line wouldn't make sense if A was negative. So A has to be a positive. Now, having said that, when I was in school, A had to be positive. You had to leave A as a positive term, which meant you sometimes have to change every term to its opposite to make A positive. This book is not going to do that. Sometimes they're going to leave it positive, sometimes it's going to leave it negative. I will show you the difference. I'll show you how to deal with that. Okay? We want to try to always leave A as a positive to make it easier for you when you're in chemistry. How many of you had chemistry already? Taking it now. Okay, good.
Already?
I don't have to take it.
All right. Okay. Point slope formula.
A squared plus B squared equals C squared.
No.
Y minus y1 equals m.
Times x minus x1. There you go.
Forgot that part.
Point slope. Copy down the point slope formula, please. Now the subscripts. Sub means down. Script, label. The subscripts, 1, y1, x1. They're just labels. They're like using a different variable. So y and y1 are not the same number. Okay? And so x1, y1 is some point on the line. M is still the slope. Okay? Point formula. Is it coming back, you said?
Yeah.
Oh, good. Good, 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 good. I was afraid you said it isn't coming back. Yeah. I'm like,
No.
I like that song. We'll play that song later.
No.
Baby, come back.
Pray I dig my own grave.
Hey, you guys are the ones suffering. I got it.
Ooh, shots fired.
All right. Anybody not finished copying? This equation is the most useful for writing the equation of a line. If they ask you to write an equation, this one's the most useful. All you need is a point and the slope. Okay? All you need is any point on the line and the slope. So it makes it really easy to write the equation of a line using this. Okay? Now, I write this a little differently. This is the way the book does it. This is the way I write it. I put boxes. When I write it down, I say y minus box equals box times x minus box. And then I have to remember that I'm looking for an x and a y and an m in those three boxes. The reason I write it this way is because when I'm applying it to write the equation out, I know where I want to replace things. My experience is some students, none of you I'm sure, but some students struggle when you look at this and you see all those variables and you think, where do I put what? Okay? I think some people struggle with that. Because of that, I found it more useful to think of this equation this way. So the x and y, I'm never going to replace. They're just there. Okay? If I have an equation of a line, I should have an x and a y in it. Unless it's vertical or horizontal, then I'll only have one or the other. Okay? So, in this situation, we want to, thank you. So, I think you'll find it more helpful to think of this equation this way. It'll help you know where you're going to place things when it's time to write the equation out. Okay? Here we have an equation. Y equals 3x plus 4. Y equals 3x plus 4. The easiest thing to do with this form is to graph from this form. What form was this? Slope-intercept. What's valuable in this form that will help us graph?
The slope is 3.
The what?
Slope is 3.
You might be saying it right, I'm just not hearing you. Just say focus 3.
I said the slope is 3.
Oh! That makes a lot of sense. So you're saying 3 equals, I started writing M, but I want to write the word out. 3 equals the slope. Okay, what else is useful here? The 4 is the y-intercept. Now, pretend for a minute I'm in your group. And you tell me, hey, the y-intercept is 4. And I look at you with this blank look in my face, meaning I have no idea what you mean by the y-intercept equals 4. So how would you re-describe that to me? Aaron?
The line crosses the y-axis.
So the line crosses the y-axis at 4. Now how does that help me? So I'm still looking at you a little bit of a blank. So what do you say to me now, Nikki?
The tall line.
The tall line?
They're both tall.
Oh, you mean it goes up and down?
Yeah, the one that's vertical.
Okay, the vertical line. Yeah, that's right. That's what that word is. Vertical line. I'm playing your group member here. So what about the vertical line, Nikki?
That's where the point goes.
What? Oh,
Line goes.
I put a point. Where now?
On 4.
On 4. On the, right here?
On the
Right there?
axis.
On the y-axis. So what you're telling me is I need to put a point right here. So the y-intercept, every one of you, by the way, described this properly. It's 4 is the y-intercept. 4 is where the line crosses the y-axis. But sometimes that group member just doesn't get it yet. You need to actually tell them. That means that when I start graphing my line, I'm going to put a dot on the y-axis at 4. Right? So from there, Paul, what do?
Oh, no, I was gonna ask, is it still recording?
I think so.
I know it's open down there, but I just don't.
I think it's still recording, Paul.
Okay, good.
I'm just moving it out of my way. Thank you for double checking with me. Can someone tell me what do I do now? I got a dot. I need a line. Jacob?
You can go over, if you're going down, go over 3 and down 1. Or if you want to go to the left, go over 3 and up 1.
So if I go to the right, you say I can go over 3 and down 1?
No, it's right.
Oh.
It's rise over run, and so you put 3 over 1.
Oh, let me write this down because I didn't have this in my notes, did I? So slow means rise over run, you said?
I was
Yeah.
trying to figure out what that was called again. Like, yeah.
Okay. And so how does that help me? I got 3 here.
Well, because you don't really have 3 over 1 in the number.
Oh, but you're saying I could have this as 3 over 1?
Yeah, because
Now we're talking.
it's a
It's a fraction. We always want to think of our slope as a fraction. That's correct. And the slope is the rise over the run. And the slope is 3. Paul?
I really want to say this because it's been bugging me since you put 3 equals slope up there. 3 equals slope and slope equals rise over 1, so now therefore 3 equals rise over 1, that's how it is 3 over 1.
Right? So what do I do with it?
You apply it to the 4. You go over 3 and up 1.
I go over 3 and up 1?
I mean up 3 over 1.
Oh! So he said I apply it for the 4. So I start here, and I go up 3 and right 1. Which is there. What if I don't have room on my paper?
It's okay.
Then I can go down, Damien says. So if I go down, how far?
Down 3.
1, 2, 3, and then what?
Over 1.
Bunch of back.
But to the left. Okay, I could go down 3 and left 1. Okay? If I draw my line, it's something like that, don't I? Okay? And that's how we graph that from slope intercept. I'd like to ask a question, but I'm afraid someone might raise their hand. Is there anybody in here who doesn't remember ever doing this ever in your life? Good. No hands are up.
His elbows up.
Just Ariana's hand, and that's okay. She'll be lost. Ooh, graphing this one. What form is this one in, Taylor?
X1. C.
Is this slope intercept?
This is
Emily says no.
this is standard form.
Standard form, isn't it? Taylor changed her mind. This is standard form. AX plus BY equals C. Okay? Now, if I wanted to graph this, I could change this to slope intercept, couldn't I? All I'd simply have to do is move my 3x over in this case, wouldn't I? But if there was a number in front of the y, I'd have to continue and solve for that, wouldn't I? To solve for the y, get the y all by itself. So I could do that. Yeah.
There's already dots in our paper.
Really?
There is.
Yeah, I don't know. I guess I have little dots here on this one. I don't know. They don't go there, so
Oh yeah.
I'm not sure why they're there, but that's okay.
I was asking if they were significant or not.
No, it's just a mistake if they're on your paper. All right. So I want to show you something that I'm sure you've seen before, but it's different. I don't want to do this the same way we graph the other one. We already know how to graph the slope intercept, don't we? Sometimes they'll ask you to identify the x and y intercepts. Okay? Sometimes they ask you to identify the x and y intercepts. This is why there's dots there. They didn't get erased. Because I did this. If I'm at that point right there, what's the ordered pair for that point? 0, -4. What's the ordered pair for this point right here? 0, 12. What's the ordered pair for that point right there?
0.
What's the ordered pair for that point right there? Okay, so if we look at those 4 points we put there, what does every one of them have in common?
0.
What is? X is 0. So everywhere on the y-axis, the value of x is 0. So if I put 0 in here, I'm going to find the y-intercept. If I put 0 in for x, I'm going to find the y-intercept. So if I put 0 in for the x, what is 3 times 0?
0.
And so I get 0 plus y equals 15. So that means y is 15. So I can come up here at 15 and put a dot. That's going to be my y-intercept. That line from this equation has to pass the y-axis at 15. Okay? Now, Amelia, about to call on you here. You're just going to tell me where's this ordered pair. What is it? What ordered pair represents that dot?
0 and 10.
10, 0, right? 10, 0. And Bishoy, if you're looking up here, what is the ordered pair for that dot? Negative 10, 0. And Noah, what's the ordered pair for that dot?
2, 0.
2, 0. Do I need a fourth one, or do we already realize what's the pattern now? Everywhere on that line, the value of y is 0. Everywhere on here, the value of y is 0. So if I put 0 in for y,
It's 3.
oops, there, equals 15. Okay? If I put 0 in for y, then 3x equals 15. What do I do to solve for x?
Divide by 3. And then
Divide by 3, so x is
5.
5. So I get that one there.
Look at us being all smart.
And then, if I draw my line through there,
46.
I get that line right there. Okay? How many points does it take to draw a line? To know where the line's going to go? 2. That's all it takes is 2. So if I know where it crosses the x-axis and I know where it crosses the y-axis, I'm going to be good unless it crosses both of them at the same time, which would be at the origin. So as long as the graph doesn't cross at the origin, then I can use the x and y intercepts. And this standard form works really good for finding the x and y intercepts. Here's the tip, though. What number is in front of the x? Let me back up. What number is in front of the x?
3.
What number is in front of the y? Do they both evenly go into 15?
Yes.
Then this is a really good method. Okay? This would be a really good method. If I wanted to graph this one, 5x minus 2y equals 10. Will that method work really well for this? Yeah. What number's in front of the x? What number's in front of the y?
2.
Negative 2. Will they both go into 10 evenly?
Yeah.
Yeah. So I could find the xy intercepts to this. And this is how I do it. You can't see this at home very well, but if I cover the x up with my hand, it makes it disappear, doesn't it? Except you can see the on the back of my fingers probably. But the point is, it's not there anymore. It's like taking this big eraser and saying, that's gone. I'm left with negative 2y equals 10. So what's y equal? Negative 5. So that's where it's going to cross the y-axis. If I take my big eraser and I do that, and cover up the y, then saying 5x is equal to 10, so x would equal 2. So it's going to cross the x-axis at 2. Okay? So we can easily find the xy intercept if those coefficients both go into, if they both go into that other number, evenly. Okay? Any questions on that?
Yeah, where'd my spring go?
Here's another example. Is that method going to work well on this one?
No.
Now try it. I'm going to pause this in your group.
Yes, actually.
Use the x and y intercepts. Use x, y intercepts and try to graph this. Let's look at this together now. If I want to know, are you listening? If I want to know where it crosses the x-axis, what do I do?
5 by 4.
No.
Put 0 where x is at.
Put 0 in for what?
X.
I want to know where it crosses the x-axis.
Put 0 in for y.
Put 0 in for y. So if I want to know the x-intercept, then I'm going to put 0 in for y. So 8x plus 4 times 0 equals 16. What happens to my 4 times 0?
It cancels out, so it's 0.
So it's just nothing, is it?
Yeah. So 8x equals 16. 8 divided by 16 is 2.
Okay? So the x-intercept is 2. Now, if I want to know where it's crossing the y-axis, what do I do?
Same thing.
But do it with the y.
Brandon?
Plug 0 in for x.
Plug 0 in for x. So if I want the y-intercept, I put 0 in for x. So I get 8 times 0 plus 4y equals 16. And 8 0 cancels, leaving me with 4y equals 16.
5 by 4.
So y equals 4. So then I can draw my line. I can draw my line through my dots. Okay? Now what I was showing you before is on your paper, it's hard for me to do on the board. If I put my hand on here, strange things happen. So if I put my hand over this, I guess it's working. 8x is equal to 16 is what we get. So if I cover up the y, that's going to tell me where it crosses the x-axis. If I go down here and cover up the x, it's going to tell me where it crosses the y-axis. Okay? That's what makes this problem easy. You can copy it down on your paper. You probably don't have to do all this work after you've done a few of them. You probably can cover it up and say, well, 4y equals 16. That means y would have to be 4. And then you can plot that point. You can cover this one up. 8x equals 16. That means x would have to be 2. You can plot that point. Okay, any questions on that? You remember the formula for slope? What's that? No, that's a slope-intercept form. How do you find the rise and the run? If you're given 2 points.
Oh, it's, yeah. It's,
You're going to have x's and y's.
Y2 minus Y1. Is it Y1 minus Y2?
yep.
That works. She said y1 minus y2 over x1 minus x2. I might have written it the other way, but it doesn't matter.
No.
It's change of the y's over change of the x's. Okay? If you said y1 minus y2, as long as you have x1 minus x2 in the bottom, you're okay. What you can't do is subtract the y's one direction and subtract the x's the other direction. You can't do that. That'll change the sign. It'll give you the wrong sign. It'll give you a negative when you should have a positive, or give you a positive when you should have a negative. Okay? long as you subtract the same way, then you're okay. So, if I want to find the slope of these 2 points,
You plug them in. So it would be 4 minus 2, then 2 minus 6.
4 minus 2, and on the bottom, 2 minus 6.
Did you get 2
Slow
over
down,
2?
Paul. Thank you for your help. He's calling this x1, y1, x2, y2, and he's saying 4 minus 2, so he's got to say 2 minus 6. See the direction in which he subtracted? That's what I was talking about. As long as you subtract the same direction both times, it doesn't matter how you label your rule here. Okay? The only significance in my labeling is that it's 2, then 1, 2, then 1. Okay? Now, what do you think the most common mistake I get from students is in finding the slope like this? What's that? They put it out of order. That could happen. It's not the most common mistake, though. Paul?
They'll do 4 minus 2, then they'll do 6 minus 2.
That's what he was just saying. That does happen, but it's not nearly as common. Aaron? Emily, sorry.
Is it that they put the X on top and Y on
That's
bottom?
exactly it. They accidentally put the run on top and the rise on the bottom. Okay? Remember rise over run. I think everybody remembers that. But then they get mixed up and they take it for granted, and because the X's are first, they put them on top. Remember the rise, the Y's go up and down. So we have to put the Y's on top. Okay? The X's go on the bottom. All right? So if we finish this now, 4 minus 2 is 2, and 2 minus 6 is negative 4, and that reduces to what?
Negative
1
2.
negative 2.
Negative 1 over 2. Remember the bigger numbers on the bottom, it's going to be a fraction. Okay? So my slope is negative 1/2. Now, it doesn't say it on here, but the point of this question was for you to write an equation of the line that passes through those 2 points. So the question really is asking, write the equation of the line that passes through, bless you, the given point. Okay? That's what the book is going to ask you. And then they're going to give you 2 points. And the first thing you're going to have to do with those 2 points is find the slope, which we already did, didn't we? Now, if they say in standard form here, then you'd have to write this in standard form, but you don't have to start in standard form. You just have to finish it in standard form. The easiest way to write this to start with is going to be the formula I gave you. Remember, y minus what? Box equals box times x minus box. And then underneath it I had here what went in this first one. Y, an M, and an X. Okay? So I need an X, a Y, and an M. Do I have the M? Yeah, what is it? Negative 1/2. I'm going to raise this up a little bit so we can see. I can't. Well, hold it up here for a second. Amelia. They haven't picked on you yet today? Oh, no. Amelia, this is going to be really hard for you. You're going to have to choose which of those 2 points we're going to use.
Which of the pairs of the
Yep. Which ordered pair do you want to use? 6-2 or 2-4? 2-4. Think she's right? You can use either of them, so she is right. She can use whichever one she wants, and she chose 2, 4. Here's the most common mistake. Watch, don't write. People do this. Because they gave them to me. The ordered pair was 2, 4, so I put them in my blanks, 2, 4. What's wrong with it?
The 2 goes with the X.
The 2 is the X coordinate, the Y was the 4, right? So they don't go 2, 4, they go Y minus 4, X minus 2. Okay? That's how we have to do that. Now, if the directions simply said, write an equation of the line, you can stop right there. That's an equation. It's of a line. You did an awesome job. It's easy for me to correct. Doesn't matter if Michael chose 6, 2 or Amelia chose 2, 4. As long as he put the 6, 2 in the right place, and she put the 2, 4 in the right place, they've got the right equation. Okay? If they said put it in standard form, though, then we have to convert this. So let's do that together. I'm going to get rid of the boxes, clean this up. I'm going to actually distribute my negative 1/2. So I'm going to say y minus 4 equals negative 1/2 x plus, right? Because a negative times a negative is a positive. What's 1/2 times 2? Some of you struggle with that. Let me ask you this question. What's 1/2 of 2?
1.
1. So what's 1/2 times 2? 1. The word of implies multiplication. Half of 2 means 1/2 times 2. And you all know what half of 2 is. If I had $2 here and said I'm going to give you half, you know you're getting what? $1. Okay? So, is this in standard form? Yeah, standard form. That's what we want. What was standard form?
Y now. Like Y.
What was standard form?
I don't know.
Go ahead, Aaron.
X plus BY equals C.
AX plus BY equals C. This is what we're looking for. So I need my X's and my Y's on the left side and all my other numbers on the right side, right? So what do I need to do to that? I guess that's good right there. What do I need to do to that to make it look like this?
Add 1/2 x to both sides.
Okay, so I'm going to add a 1/2 x to both sides. So, and remember it's AX. I'm going to write the x first. 1/2 x plus y minus 4 equals 1, because this cancels out.
Then add 4 to both sides.
Someone new, Paul. Share the wealth.
Then add 4 to both sides.
Add 4 to both sides. And so I get 1/2 x plus y equals 5. Mackenzie, is this in this form? Yes, it is. And you know what? The scary thing is sometimes the book might leave that as the answer, and that really annoys me. Because it's violating one rule. What was one rule of standard form? A has to be positive, which it is.
They have to be integers.
They all have to be integers. And this is a fraction, isn't it? So we can't leave it that way. So what we want to do instead is multiply everything by what? By 2. Because 2 times 1/2 is 1, and it cancels my 2, doesn't it? So I said multiply everything, and I put parentheses. So really you're going to distribute the 2 to everything. So 1/2 of 2 is 1x. And then 2 times y is 2y. And then 2 times 5 is 10. Now if you said 1x plus 2y equals 10, that's fine. You can leave that 1 in front of the x if you want to, but the book is never going to do that. That's one place where I and the book authors agree. We're never going to leave a 1 there. Doesn't make it wrong, it's just saying we're not going to do it. Because we recognize that 1 times x is x. Yeah, it'd be okay though. Worst case scenario is later today I'll take that staple out of my pants. Alright. Any questions on that? That is the last example. Now you have a lot of homework today, but listen to me. You have nearly 20 minutes now, and you're going to get 35 minutes tomorrow. Okay? We have a half day tomorrow. I'm not going to add anything new to your workload. I'm going to give you all period to work on this. Okay? I would like you to do this on graph paper. And if you need graph paper, well, I found a textbook. I found my textbook. Probably don't need to record all this. So here's your lesson. You should have a good example what to do. There's more examples in the book. Work in your group on it.